All right, welcome back, 8th grade. Let's jump right back in. Problem 3.2, solving linear inequalities symbolically. So here it says, graphing methods are helpful for estimating solutions of inequalities. If you want exact results, you can use a symbolic reasoning. You already know how to use properties of equality to solve linear equations. To solve linear inequalities, you will learn to use the properties of operations on inequalities. So before we start, I want to just clarify, this is a very, very unique lesson. It's one of those problems that we've had in the past where you actually discover some kind of rule in things. And so we're going to be doing that here. And so it's going to bear with us in the process and just make sure you're just thinking through what's going on and making sure you're making observations. All right, let's take a look. All right, part A. Suppose that two numbers, Q and R, are related by the inequality Q is less than R. So draw a number line such as the one below. All right, there it is. Let's keep reading. Locate points to represent the numbers Q and R when both Q and R are positive numbers. Now we have to remember that the statement here is that Q is going to be less than R. So for A1, I think what we're going to have here is we're going to have these spots where if they're both positive, then I would say that we would have Q here and R here. All right. A2, both Q and R are negative numbers. All right, so remembering that Q is still less than R, so then we both have a negative, so it'll be equal, Q would be over here, and R would be here. And A3, where one number is negative and the other is positive. So still seeing that Q is less than R, so that means that we'd have like Q over here and R over here. All right, part B. So suppose, so we're going to continue to suppose that Q is less than R. So complete each statement below with the inequality symbol, less than or greater than, so that the results for all values of Q and R will be true. Use a number line graph from question A and ideas about geometric transformations to explain each answer. If it's not possible to write an equality statement for that is true for all values of Q and R, give examples to show why each case is that way. All right, so B1. We're still remembering that Q is less than R. And so we're looking at what would happen here if both sides had 23 added to them. It would still end up being the same situation because we would be adding the exact same information there. So Q would still be less than R. And also you can see from what we had up here, if I added 23 to both of these would both just shift over, these would shift over, and these would shift over. So it would still end up being true in that case. All right, B2. Still having Q is less than R. And if we took away 35 from both of them, subtracted 35 from both of them, notice how if we did that, they would both move the same direction on the number line. So it ended up being the same situation. All right, B3. So taking Q is still less than R, and we had both of those, and we multiplied them both by 14, they would still both move in this way together. So it would still stay the same, that this would be less than that. All right, B4. We're multiplying them both by negative numbers, and this would be the case here. So interesting, this one's different. Notice how that if we had this same situation and multiply them by the exact same work, what would happen? They'd become the opposite of what they are. And this Q would be here, and this R would be here. So it turns out that that would be further. Let's see if that's the case here. So they're both negative. The opposite of the R would be here, and the opposite of Q would be over here. So that would be the opposite. In this case, the opposites, they would be reversed. So it turns out it's the other way around, that this one would go the other direction. It makes the Q would end up being bigger when multiplied by that negative number. All right, now we're dividing by 5. So Q is less than R. So here, if I divided it by 5, it would both come this way. Dividing by 5, we would both go this way, probably. Dividing by 5, they would both come this way. So it still would be the same. So Q, in this case, would still be less than R. All right, now we've got them both be divided by a negative number. So if I come to this one, and if I divide by a negative number, it's going to be doing the same kind of thing where it's going to end up being opposite. So it makes it smaller, but then on this side, and this would be smaller, but it'd still be over here. So it turns out that the R would be smaller. Same thing over here. It'd be the opposite, but it would end up being that this would shift differently. Same thing in this case too. These guys would reverse, which meaning the q would be bigger. So it turns out that in this case, it would change the direction of the inequality. All right, part C. What do your results from question B suggest about how working with inequalities is similar to and different from working with equations? All right, so as we saw in some of our work from previous lessons, that when we actually have an equal sign, everything kind of works, everything stays balanced, and end up having that work there. And we saw some cases where the inequality symbol being greater than or less than, it just would come straight down and adjust. But something happened when the values of the final multiplication and division were negative that had us change the information. So the inequality symbol changed directions. And it turns out that's a really big mathematical principle, that when you're solving for inequalities like this, and you ever multiply or divide by inequalities, you have to reverse this direction of the inequality symbol for it to still be a true statement. So it looks like on part D we're going to be practicing this a little bit, but just make sure you remember that, write that down, that when you're working with inequalities and solving for inequalities, anytime your last step is dividing or multiplying by a negative, the direction of the inequality symbol will have to be switched. All right, here we go. Use symbolic reasoning to solve each inequality, then make a number line graph to show the solutions. So we'll do these guys here. All right. Number 1, 3x plus 17 is less than 47. All right, so we're treating it just like before. So to minus 17, this is going to be gone. 3x is less than, and this is going to be 30. Divide by 3, divide by 3. It's positive 3 I'm dividing by, so it turns out it would be x is less than 10. And so when we graph this, it will look like this. Be open circle at 10 going that way. Next one. 43 is less than 8x minus 9. Okay, so we're going to do plus 9 here, plus 9 here. This is going to cancel. This will end up being a 52 is less than 8x. Divide by 8, divide by 8. Turns out this is going to end up being 52 divided by 8. It's going to go in 6 times. We get 4, so we'll go ahead and leave it at this. You know, it's going to go, actually, decimal point 0, bring that down. So 6.5. So it's going to be 6.5 is going to be less than x. And the graph for that, if you recall, it's a little bit tricky when the x is on the other side. But if I reverse it around, it ends up being like this. X is greater than 6.5. So I'll put 0 here and 6.5 here. It turns out what we would do is we would have an open circle going this way. All right, number 3. Negative 6x plus 9 is less than 25. Now I've got to be careful. There's that negative 6. So that final step, we have to remember to reverse the inequality symbol. So minus 9 and minus 9. This is going to cancel. I've got negative 6x is less than 25 minus 9 is going to be a 16. And then when we do that work, we're going to do divide by negative 6, divide by negative 6. But it turns out because of that process, we would have x. We were going to change the inequality is coming here. We have this be a negative 16 over 6. That's negative. That's going to be what we can leave it as there. Now, when we do a number line for this, it's going to be negative, so I'll have 0 here. Now this 16 over 6, it really ends up being like a 2 and 4, 6, right? When we do that, so it's going to be down here in this area. But we have a negative 16 over 6. We're going to have here an open circle, and it's going to be pointing this way. All right. 14x minus 23 is less than 5x plus 13. Let's get our x's over here. So minus 5x minus 5x. It's going to cancel. This is going to come down and be a 9x. I'm going to do this 23 over here. So I'm going to add 23 here and add 23 here. That's going to cancel. This is going to be 9x is going to be less than 36. Oh, I like that. Warm fuzzies in that case. Divide by 9, divide by 9. x is going to be less than 4. Now remember, because it's a positive we're dividing by, we don't change the direction of the inequality symbol. And so we'll have our number line, got 0 and 4. It's going to be less than, so it's going to be open circle going to the left. All right, here it is, number 5. 18 is less than negative 4x plus 2. Again, there's that negative 4x. So we're going to be dividing by that. That means we're going to be turning around our inequality symbol. Let's go start here first. So minus 2 and minus 2 is going to cancel. We're going to have here 16 is less than negative 4x. Divide by negative 4, divide by negative 4. That means this is going to end up being an x. We change the direction of the inequality symbol. This will be a negative 4 in that case. Now we can leave it that way as that answer, but remember when it comes to graphing, it's easier if we reverse the location. So if I do this and this, I also have to reverse the inequality symbol there. It's kind of a unique one, but either of these are accurate, but this one helps us with graphing more on that number line. So here we go. I have 0 and negative 4. In this case, because it's going to be that way, I will have an open circle that way. It's going to be going this direction. Here we go. Number 6, 3,975 plus 6x is less than 995 plus 17.95x. Hey, we did this one. We've done this one back the other day. Looking back, this is when they had us do with all this information here on 3.1. So I happen to recall the answer for that because I can go back a couple pages. It turns out that it was right here. We end up getting that 249.4. So I'm going to go and do that, leave the x over here. So x is going to be here, 249.4, and it's going to come down just like this in that case. So save that time and that worked there. But we'll reverse it for graphing it. So x is going to be greater than 249.4. So then that would look like this. So if I have here 0 and 249.4, it's going to end up being an open circle going this way. All right, good work on that one, guys. We're going to jump into the ACE work here, and for this assignment for 3.2, you are looking at problems number 4 through 8. Let's take a look. All right, 4 to 7, solve inequality, then graph the solution on number line. So 4 through 7 is just like we just did on part D. Solving, being careful of the inequality being a negative, and it looks like you're going to have that specifically on number 7. You'll see that's going to come into play here. Okay, so be careful on that one. And then on part 8, it says use the graph below to estimate the solutions for the inequalities. And so in this case, you're looking at these two guys, getting an idea where you think they might be, because some of these are actually going to be graphed, and they're all across here. So where do you think the solution would be? Then use symbolic reasoning to check your estimates. So you're kind of getting an estimate and then actually solve and figure out where it's going to hit on there for those. All right, that's it. We'll catch you next time, guys. All right, later.